My name is Dr.B.V. Rajanna, Associate Professor, Department of EEE, MLR Institute of Technology, Hyderabad. Today I am going to deal about the subject power electronics and the power semiconductor devices. My overview of presentation today is semiconductor devices. So here the power diode, first I will discuss about the power diode, and next I will discuss about power transistors, power BJT, power MOSFET and IGBT. So power BJT is nothing but bipolar junction transistor, bipolar junction transistor, and MOSFET is nothing but metal oxy silicon field effect transistor, and IGBT is nothing but insulated gate bipolar transistor, insulated gate bipolar transistor, and this is metal oxy semi field effect metal oxy semiconductor field effect transistor. Okay, semiconductor field effect transistor. So power transistor are of three types. So power BJT, power MOSFET and IGBT. So power BJT is nothing but bipolar junction transistor, power MOSFET is nothing but metal oxy semiconductor field effect transistor, and IGBT is nothing but insulated gate bipolar transistor. So we will discuss briefly about these three power transistors and power diode in detail. So first power diode we will discuss. So this is the basic symbol of the power diode. So diode is nothing but it's a device which makes current to travel only in one direction in a circuit. So this is a power diode basic symbol. So it has two terminals, anode and cathode. So anode is a terminal through which current enters and cathode is a terminal through which current leaves. So here IF is a forward current, and this is a symbol, and here it is looks like the physical structure of the power diode. This is the structural feature of the power diode and the symbol. This is the structural feature. This is anode terminal and this is cathode terminal, and this is the drift region, and this is the junction J1, and these are the layers. And here anode, cathode are the two terminals of the diode, and this is the diode voltage. These are the VI characteristics of signal diode and power diode and ideal diode. So here we can see here the forward biased power diode. So here this is the circuit, the diode, this is the diode voltage. This is the anode and this is the cathode. Anode is the terminal through which current enters and cathode is the terminal through which the current leaves. And here as you see the positive to the positive. So it is the forward bias and the negative to negative is the forward bias. So forward bias power diode. So here positive to positive is the forward bias and negative to negative forward biased. So this here the diode is in conduction state. Here as you see VI characteristics of the signal diode. So here the forward voltage drop, this one, here the graph drawn between current and diode voltage. Here the cut-in voltage is 0.7 volt, 0.7 volt is the cut-in voltage, and here reverse recovery mode, diode reverse recovery mode is this one. So the graph is like this, and here the VI characteristics of power diode, this is like this, and here VI characteristics of ideal diode. So ideal diode characteristics is this one. Reverse recovery characteristics, here as we see variation of forward current IF here, So here it carries like this. So here it comes like this, and like this, and here this comes like this. So this is the forward voltage and this is the forward current, and this is the power loss in the diode. So power loss diode is this one. And the power transistors we discuss now. Types of power transistor: bipolar junction transistor BJT and metal oxide semiconductor field effect transistor. And so MOSFET this is, and insulated gate bipolar transistors IGBT we discuss now. So first we will discuss about power BJT. So 3-layer 2-junction NPN or PNP type this is. So bipolar means current flow in the device is due to the movement of both holes and electrons. So it's a 3-layer 2-junction NPN or PNP type, and bipolar means current flow in the device is both due to the movement of both holes and electrons here. So here BJT is having 3 terminals: collector, emitter and base, and 3 layers NPN. So here base, it is traveling like this, the current is traveling like this, so that's why it is NPN. If it is traveling this side, it is PNP. If the current is traveling this side, it is PNP. If it is traveling this side, it is NPN. This is collector current and this is emitter current and this is base current. So here as we see here, this is NPN type and this is PNP type. So here the based on the direction of current, the emitter current is like this here in NPN, the emitter current direction is like this in case of PNP, as we see the difference here. So this is the circuit symbol of the BJT, circuit symbol of BJT. These are the VI characteristics of power BJT. So here the graph drawn between base current and base emitter voltage. So these are the input characteristics and this is the common emitter voltage. And here as we see the graph is like this. So VC greater than VC1, and here the graph drawn between the collector current and the collector emitter voltage, nothing but the output characteristics drawn here, and the base current is increasing like this. So IB1, IB2, IB3, IB4, IB5. So actually IB5 is greater. So IB5 is greater than, IB4 is greater than, IB3 is greater than, IB2 is greater than IB0. So like that the output characteristics is increasing, and these are the switching characteristic circuit for the BJT. As we see here, we given the square signal for the base. So here this is the base resistor and this is the base voltage and this is the base emitter voltage, and this is the collector current, collector resistance, and this is the emitter current, and it is the collector emitter voltage, and this is the supply voltage, and this is the collector current, and this is the symbol. So here it is a PNP type of the transistor. If it is like this, then it is PNP. Here it is NPN transistor with resistive load. So it is NPN transistor with resistive load, this one. So switching characteristics of power BJT. So here as we seen, here the square waveform, the rectangular waveform coming like this, and here this is the base voltage waveform, and this is the base current, and this is base emitter voltage. So the base emitter voltage waveform is like this, and collector current. So collector current waveform. So collector current waveform goes like this, and here collector emitter voltage. Collector emitter voltage, the waveform goes like this. So F operating area power of BJT. So this is Tj, junction temperature less than 25 degrees centigrade at room temperature. This is at, so Tj, so at room temperature, less than room temperature. So the safe operating area, this is a collector current, and the common emitter voltage, and here as we see, this is the reverse block safe operating area as we seen in the graph. So here the graph goes like this, and this is the area of the region, and here this region is like this. So this is the vertical region, and the IB is equal to 2 minus 2, and here it is 0. Now coming to power MOSFET. So metal oxide semiconductor field effect transistor. So this is the symbol of the MOSFET. So symbol of MOSFET. So this is drain, source, gate. So these are the three terminals of the power MOSFET, and this is the drain current, and this is the physical symbol. So power MOSFET is a three terminals, drain, source, gate, as we discussed, and is a voltage control device. Gate circuit impedances is high of the order of mega ohm. Hence gate can be driven directly from microelectronic circuits using low power high frequency converters, SMPS and inverters. So SMPS, the switch mode power supplies. Switch mode power supplies, it can be used. The basic structure of N channel power MOSFET. So here we can see, here this is the supply voltage. So this is the source, gate, drain. So three terminals, and these are the layers. This is the physical structure of the N channel power MOSFET, and this is the drift region. Here MOSFET power transfer characteristics. Here this is the gate voltage, and this is gate source voltage. So here it's a load, it's a power MOSFET, N channel power MOSFET. So here this is a supply voltage, here drain, source voltage, and this is a drain resistor and drain current. And here the graph drawn between drain current and gate source, drain current and gate source voltage, VGS, gate source voltage. Here as we see the graph drawn like this, and these are the MOSFET output characteristics. As we see, the drain current, so coming like this, and the VDS, the drain source voltage. So this is the active region, this is the active region. So the MOSFET conducts, MOSFET conducts here. MOSFET switching characteristics, so here this is the gate voltage. So the gate voltage is given like this, and here this is the gate source voltage. So the gate source voltage like this, it comes like this, it comes like that, and these are the rise time, and this is the drain current. So it comes like this. So here graph comes like this and like this, and this is the drain current. So comparison of BJT and MOSFET. So BJT is bipolar device and MOSFET is unipolar device. So low input impedance here, low input impedance, and here high input impedance mega ohm, and high switching losses but lower conduction losses, and here lower switching losses but high on resistance and conduction losses. Here current control device, and it's a voltage control device. And next, negative temperature coefficient of resistance, parallel operations is difficult, current sharing resistance should be used. And here positive temperature coefficient of resistance, parallel operation is easy. And next, secondary breakdown occurs here, and here secondary breakdown does not occur. And here available with ratings 1200 volts to 800 amperes, and here available with ratings 500 volts and 140 amperes. So insulated gate bipolar transistor IGBT, it combines the best qualities of both BJT and power MOSFET, and has high input impedance as MOSFET has low on-state power loss as in BJT. Other names: metal oxide insulated gate transistor, conductively modulated field effect transistor, gain modulated field effect transistor, GEMFET, IGT insulated gate transistor. These are the other names for the IGBT, and this is the basic structure of IGBT. Emitter, gate, collector are the three terminals of the IGBT, and it is a n channel MOSFET structure, and these are the different layers. This is the body region, drift region, buffer layer, and substrate. This is the basic structure of IGBT. Emitter, gate, collector are the three terminals, and these are the different layers, and these are the junctions J1, J2, J3. This is the equivalent circuit of IGBT. Emitter, gate, collector are the three terminals, and is a n channel MOSFET, and is a NPN transistor, and this is a PNP transistor. So combination of both MOSFET and BJT, nothing but so MOSFET and BJT. So BJT, MOSFET, so both combination. So BJT, MOSFET, both combination gives IGBT. This is VI transfer characteristics of IGBT. This is the gate voltage, and this is the supply voltage, and this is the collector emitter voltage, and this is the gate emitter resistor, and this is the source resistor, and this is the collector current. And here, as we see, the graph drawn between collector current and collector emitter voltage, VCE, is nothing but the VI characteristics of the IGBT. So VI transfer characteristics, it is, so VI transfer characteristics, so it is like this, it is increasing. So VGE2, VGE3 and VGE4. So as we see here, the gate emitter voltage. So the gate emitter voltage the gate emitter voltage is keeps on increasing as VC is increasing. So the graph drawn between here the collector current and the gate emitter voltage. So as we see, the graph is increasing like this. These are the switching characteristics of IGBT. This is the gate emitter voltage. So the gate emitter voltage is drawn like this, so comes like this, and this is the collector emitter voltage and collector current. So it comes like this, and one graph goes like this. So these are the current, this is the collector current. And this is the rise time, and this is the on time, and this is off time. And these are the applications of IGBT used in DC and AC motor drives, UPS systems, power supplies, drives for solenoid relays and contactors. So these are the applications of IGBT. So comparison of IGBT with MOSFET. So 3 terminals are gate, source and drain. Here 3 terminals are gate, emitter and collector. High input impedance, here also high input impedance. Voltage control device, here is also a voltage control device, and ratings available up to 500 volts and 140 amperes. Here ratings available up to 1200 volts and 500 amperes. Operating frequency is up to 1 megahertz. Here operating frequency is up to 50 kilohertz. So these are the differences between IGBT and MOSFET. So summary, we have discussed the power diode and power transistors are discussed in detail, and power BJT, IGBT and power MOSFET are the different types of power transistors. Basic structure transfer characteristics are discussed, and next and the operation are discussed and explained. Comparison of BJT, IGBT and MOSFET are made and also explained in detail. Thank you.